For water-soluble developer, which kind of developer is used? A. Form B. B. Form A. C. Form D. D. Form C. Water-soluble developers are made up of the following chemical compounds. A. Only used on rough porous surfaces. B. Saturated in water and experience a chemical shift allowing it to fluoresce on the part's surface. C. Not to be used on galvanized parts. D. Dissolved in water. Pollution of the penetration tool. A. Will occur because of the crossover between the penetrant and developer. B. Will only take place if the part has not been cleaned. C. Will change the surface tension and contact angle. D. Will occur if the tank is not covered during the dwell time. Which kind of penetrant is less susceptible to cleaning fluid contamination? A. Type 2. B. Type 1. C. Type 4. D. Type 3. Most materials can be tested with LPI as long as the part's surface is A. Is not extremely rough or porous. B. Heated to a temperature above 100 degrees Fahrenheit. C. Cleaned with number 005 grit. D. Smooth and uniform. How often should one measure the strength of UV light? A. At startup of inspection cycle. B. When a new bulb is installed. C. Every 8 hours. D. All of the above. The water-washable penetrant's water content. A. Should be performed weekly. B. Must be checked regularly. C. Should be performed daily. D. Should be performed monthly. Increasing the temperature will A. Reduce the emulsifier time. B. Raise the speed of evaporation of penetrants. C. Require the need of a post-emulsified penetrant. D. Increase the developer time. When using a water-suspendable developer, which developer form is used? A. Form B. B. Form A. C. Form D. D. Form C. While utilizing a fluorescent penetrant, the part's surface should have a white light intensity of A. A maximum of 100-foot candles. B. A minimum of 100-foot candles. C. A maximum of 2-foot candles. D. A minimum of 50-foot candles. When the manufacturer initially sends the penetrant, A. It should be compared to the previous batch of penetrant. B. A sample of fresh solution should be collected and stored as a standard for future comparison. C. It should be compared to the previous penetrant sensitivity. D. It should be mixed with the used penetrant in order to increase its sensitivity. In a specific substance, the sound speed is A. Is constant. B. Increases with distance from the transducer. C. Decreases with distance from the transducer. D. None of the above. The following is the measurement of a defect signal in relation to other background reflections. A. Signal-to-noise ratio. B. Acoustic impedance. C. Reflection. D. Refraction. The term for the combined impact of absorption and dispersion is A. Propagation. B. Shear factor. C. Impedance. D. Attenuation. Which kind of calibration block is utilized similarly to the small angle beam block and looks a lot like it? A. A shear wave calibration block. B. An IIW block. C. A DSC block. D. A rhombus block. Other names for longitudinal waves are A. Compressional waves. B. Surface waves. C. Pressure waves. D. Both pressure waves and compressional waves are correct. The capacity to identify a tiny discontinuity is known as A. Frequency. B. Wavelength. C. Sensitivity. D. Resolution. In general, resolution rises A. With an increase in transducer frequency. B. With increased depth of a defect. C. With a decrease in the transducer frequency. D. When the transducer diameter is reduced. In the pulse echo mode, a single element transducer functions as follows. A. Needs to have a high pulse rate. B. Cannot start receiving reflected signals until the element has stopped ringing from its transmit function. C. Can only be made with lithium sulfate. D. Should be used in the dual mode. At a depth of roughly, surface waves, also known as Rayleigh waves, travel along the surface of relatively thick solid materials. A. 2 wavelengths. B. Infinite wavelengths. C. 1 wavelength. D. 3 wavelengths. The reflective surface of the discontinuity must have a diameter at least as long as wavelength in order to provide a fair chance of being detected. A. 1. B. 1/2. C. 1/4. D. 2. DAC represents A. Divergence application couplant. B. Distance application code. C. Distance amplitude correction. D. Direct amplitude code. Non-destructive testing practice test. Prepare for your NDT certification with our practice tests, featuring real-world questions and expert insights. Non-destructive testing is essential for assessing materials and structures without causing damage. Thorough exam preparation is key to becoming a certified NDT professional. Benefits of comprehensive NDT practice tests. Offers real-world questions to boost knowledge and skills. Covers diverse industrial inspection techniques. Strengthens understanding of NDT through real-world scenarios. Elevates visual examination and magnetic particle testing abilities with expert insights.